Okay, guys, good afternoon. Welcome to be here. We'll present here MapBiomas, but MapBiomas Alert, that the system that we developed to qualify and deforestation identified with medium resolution image like Landsat or even modes, and then we qualify it with a high resolution image, in our case with Planet, but it could also work with Sentinel images. I'll give some part of the concepts of the system, and then João Siqueira will open the code for you guys. Everything that we produce is free. It's open, so it's transparent. So he'll give you the code editor script that has all the open code, and then we'll make some hands-on how to use the system. Okay, he won't analyze the code. The code is very complex. You guys will have some time to look the code, and you have some doubts about the codes. João can also help you, but the idea is present the concepts, makes a hands-on on the system, and then we open for and question and to work with you guys. Just to give you a brief history, MapBiomas produce land use, land cover of all Brazil uh, from 1985 to 2018. Sorry. We have a website. All this data is open, is public. You can download the images, you can download the classification data. We can choose an year, and we have all the graphs of land use and land cover transition over these 34 years. And basically what we have is compatible land use, land cover for each year. That they are compatible to, they are being prepared to be compared each year. So we can analyze the history of land use, land change in each region of Brazil. Just main features of the methodology. It was based on Landsat, the only satellite that allows us to go back since 1985 with 10-meter resolution. It would be in 1984, but we don't have a good cover of image in Brazil from 84, and not good coverage with MSS with 80-meter resolution. Also, we don't have a good cover in Brazil. It's pixel by pixel classification based on machine learning algorithm. We use random forest, but we do a lot of special classifications, special methodology to make sure each map will be compared. Like we use the same samples to classify each year. We have post filter classification to uh, keep the comparable classification, and everything is processed inside Google Earth Engine. We have a detailed legend for all Brazil. I want to see three levels of natural forest. Then we have natural non-forest as grassland, wetland, and so on. A pasture agriculture as farming, a urban area, and it's all available on mapbiomas.org. But let's talk about the improvements and the next step. That's uh, MapBiomas 2.0. We started last year. It will continue update each year of land use, land cover, but we'll work with deforestation alerts, deforestation, degradation, and logging alerts, and regeneration maps. Basically, what Tasso said yesterday, in Brazil, we have about 11 systems to detect deforestation. Most of them, some of them based on modes, some of them based on CBERS, that's Brazilian image with Brazilian China image, and some of them based on Landsat, and some of them based on Landsat and Sentinel. Like SAD is using also Sentinel, and GLAD is the Global Forest Watch. They're starting to using Sentinel together with Landsat. The problem is we have a lot of system, a lot of deforestation alerts, a lot of overlapping data, and a lot of data that has noise. So when we talked with the producers and the users, we defined what we could help to solve this solution, this problem. And then we had three points. First, validate the alerts using high resolution images. Second one, generate customized reports for these alerts and have these reports public, open. They could be consulted and printed and accessed via API from anyone. So basically, why we choose Planet Images. Planet Image has a daily image of everywhere in the world since 2017. 2017. They start operating in 2015, but since 2017 they have daily images of anywhere in the world. And when we see an alert, we can buy historical images. Like when we buy images from Planet, we can buy 3 months before the deforestation alert, and we have images more 9 months after the deforestation. So we have this alert that came from Landsat images, MODE images that came from DETER, from SAD, from GLAD. We will check each one in high resolution image and buy image before the deforestation and the image after the deforestation. Here, just an example, this area is in Pantanal. Pantanal has some forest, some grassland here, some wetlands here. I have the image from 4th of September, 2017, and that's the image on 5th of September. You see, I'm showing on that side the area that was deforested, and then you see this area was being deforested already, and you see the tractor lines here in the image of 5th of September. Then you have the image of 6th of September. They finished to cut this area in 6th of September. In 13th of September, they started to cut this area. You see the polygon in the other image. 14th of September, 15th of September, 17th of September, 19th, they started to cut here and here. 20, 22, they started to cut this area. 24, 26, 26, 25, 26, 27, and 1st of October. That's 800 hectares that was deforested in 1 month. Okay, and we have like daily images that we are not using daily image to identify it. Okay, we identify with medium resolution, then we buy daily image for 1 year, so we can now use this image. At this point, we are using just to qualify the alert. The image before deforestation, image after deforestation, but we'll have a lot of image to understand the process, how long it takes, how to understand if they burned the area before the forest, if they burned the area after that, all these images will be available. So basically, we get deforestation alerts for all the systems in Brazil. We use Google Earth Engine to validate it, to get image before deforestation, after deforestation. We make a new classification here using random forest to refine the polygon of this deforestation, and we add to a system that's public, open, for use, to consult, and to with APIs to integrate with any system. In detail this process, we receive the alert, we make a pre-processing to remove noise. So we have MapBiomas saying where is forest. With pre-processing, we remove alerts that it's not in forest. We have a lot of cases when we use GLAD, sometimes sugarcane or planted forests are marked as the deforested area. So we remove it, some noise, discard some of these alerts. So we make a visual interpretation to discard other kind of noise, like wetlands when they dry or it's wet. Also, there is a alert there. We discard that. Then we have an API with Planet that download all the image that was approved to a Google Cloud Store. It's automatically. João also has a GitHub with this code that downloads this. Oh, sorry, this API with Planet that copy the image from Planet to Google Cloud Store, and then we have an code that go copy from Google Cloud Store to Google Earth Engine. Okay, that's a process that's automatically but takes some time. Like João will give more details, but we can copy around 40,000 images per day. As we are talking about 1 million of images, that's a problem here. Once inside Google Earth Engine, we use random forest to classify. That's the process that we will show you guys here today. Today, we collect some samples of what was deforested and what did not change. And we use the images from before and after with 8 bands, all the bands before, all the bands after, and Random Forest can classify what has changed. Then we put this on a database and it goes to the public. Okay. Just to give some idea, in 1 month in Brazil, we have more than 100,000 alerts. So it's a lot of work. We're still trying to make automatic, like do not try to collect samples. We use all the samples that we are collecting is going to a database that will make automatic classification later. That's the system that João will show you. We can select the period that we analyze, select the state, the biome, the state, the number of the alert. It will bring all the images here. And then we'll make the classification on the other side. João, you'll get in details. After that, we'll cross this alert with all public data in Brazil. We'll cross it with conservation units, indigenous land, settlements, legal reserves, and the rural property. Now we have public, rural public, all the properties in Brazil, almost all. Not everybody has declared, but they need to. And we have permissions to deforestation and areas that was blocked already. They had the deforestation in the past, and it's blocked. And instead of showing I will get here in the website. I have a lot of tabs. That's our website, okay? So here I can access all deforestation alerts. We have in 2019 7,700 alerts in Brazil. In each of these areas, you can come close. As you approach, they are individualized here. When you click in one of them, you can see the image before deforestation and image after deforestation. For all 7,100 images in high resolution image, so there is no doubt about this deforestation. And all and all this deforestation has a report. While it's opening, I can see this using Google Images background. I can see this using MapBiomas map. So for all this deforestation, I can also check land use land cover map from 1985 to 2018. And here's the report. This report is using our fiscalization entity, the entity that apply fines. So we have all the data that it's needed to apply a fine. We have coordinates, we have the image from the code of the original image from Planet image, the polygon in before the date 11 of August and 31 of December. I will get other one with property information. You see, when I have information of the properties, I can add here all the properties of Brazil here. It should be here in a moment. That's municipalities. Oh yeah, it's in gray one. So in gray, I have all the properties of Brazil. And when these deforestations happens inside a property, I have also here an image of the deforestation inside that properties with all the protected areas around rivers, all the nascentes, the starters of the river, where the river is born, origin of the rivers. Okay, perfect, thank you. And the state, and all the informations about if it's like it's a region that the property has declared it's reserved, it's protected, and even so they deforested here. The history of this area, so I can look the last 7 years of this polygon, and in this case it's all forest. So the owner cannot say that, oh, it's abandoned area and then I clear, so it's forest all the last 7 years. And it's not authorized. If it was authorized, this was green, so it was authorized by the law. And the last one here, we have a generalized polygon and some vertices that's used to make the fine. So we expect in near future send the fines by mail. So you don't even need to go to the area. We send the fine by mail, and this with this kind of detail, and for all deforestation in Brazil. Okay, we are checking all deforestation, and we have some agreement with the fiscalization agents of each states, prosecutors from state and federal prosecutors, and so and it's all public. Okay, so if I can come here to download. Oh, I open this. On another user. So here on download, I can download all shape files, okay? Or I can access the API that's open, that's documented for, you can make authentication here. You create your own authentication with your user. You can list biomes, you can list states, you can list here all the alerts, and you can access this report with all the information. That's the standard data that we receive. The source of the origin of the alert, the state, municipality, biome, geometry of the deforestation. So it's all public, and one can connect this and put in their platform to show deforestation side, conservation units, and territory that you want. And the last thing that I will show, we are preparing also some graphs with the results for Brazil, the deforestation inside each of municipality, the deforestation by state, and the history of deforestation. So we have a lot of graphs to check if the deforestation is increasing in each area. It's also all public. Okay? And with that, I will close our, that's the same last slides here. Information is public by website, reports, and APIs. That's the website that you just saw. That's some example. So we have each group of that, it means that there is 4 deforestation alerts inside in this region. That's the graphs and the API. That's it. If you have any doubts about concepts, feel free to ask now, or João will get in the codes. We'll make some exercise about how to build these alerts, because again, everything is open, everything is transparent. You can now, planet images are paid. We buy for Brazil something like 10% of Brazil that we can use for the next 3 years. And we activate it only when we have an alert. Okay, we didn't buy for all areas on Brazil. We bought 10% of Brazil, and then we say, okay, buy in this alert, buy in this alert. So we'll just buy image where we have alerts. Okay, so image is not public, planet image is not public yet. Maybe Norway has a way to buy planet image and make it free for all tropical forests. So maybe next year it will be changed. But we have this code also adapted to use Sentinel images. So you can make alerts from modes and Landsat and make the previous image and after image with Sentinel images also. Okay? Handouts?
So the one step wasn't clear to me where you have the polygon and the random forest classification. What is the polygon manually drawn and then a pixel sample going into classification?
That's exactly what we show. João will show.
Okay.
But random forest classification automatically.
I have a question. What's the advantage here to use the planet compared, for example, to Sentinel imagery to verify, for example, the alerts and clear cuts? So basically, it's a dense in a time series, I can imagine, but there are other problems with spectral reflectance that comes with planet.
We have the planet image is we have a daily coverage. That's better. For some deforestation, like in Atlantic forest, we have deforestation of 1 hectare. That's probably, we will visualize it better with Planet than with Sentinel. But most of deforestation of Brazil, like in Amazon, they have more than 5 hectares, 10 hectares, or 100 hectares. And that will be the same. Planet and Sentinel will be the same. What we tried, that's a project to research and develop, is to make sure the judge, when they get this report, they will be sure, okay, that's forest, that's not forest anymore. That's why we are trying to use Planet. but we will also try to have both Planet and Sentinel to make sure uh, it's the cost of Planet is really necessary. We are not sure yet. That's why you are trying both. Uh, Sentinel image is very good image, and they have a reflectance much better than Planet. We also have to normalize each planet, so we have a lot of computation to make sure the image will look good in the report. And that's why we did not try to identify alerts in planet image, because all the noise of in the reflectance data, we have a lot of or a lot of errors. So we are just qualifying the alerts that exist, identified in Sentinel or Landsat. Okay, so we have both options.
Have you compared your Have you compared your dataset, your results with INPE, with tethered alerts?
Uh, we are using it to refine INPE alerts, and INPE alerts has more than 90% of accuracy. So we discard as errors a very little number of alerts from INPE, and what we are trying is just make it more detailed and make sure more easy to interpret, because the problem is less than 1% of the fines in Brazil are paid, because they go to the judge 10 years to judge it. So we are trying to produce a report that will be faster, and the property of the area will have to make a deal to repair the area. But the alerts from IP are very precise. Okay, more than 90% of them are validated by us.
And do you use this alert to update the land cover map?
Not yet. Just respond the last question again. Again, more info. Any alert that we disqualify, we give the information back to the producer. So we tell INPE which alerts was disqualified, which one was wrong, and why it's wrong. If it was seasonality information, if it was planted forest, and we give this information back to Global Forest Watch, to GLAD, and we are not use it in land cover land use map yet. We have all these new samples that's collected, what has not changed and what was deforested. But in our land use land cover, we classify just the land use, not the transition. So they are not being used yet. But maybe in the future we can try at least to make the validation of our land use land cover using these alerts. Okay.
No, just for clarification. So your system, you get the alert from the forest watch, and then you validate it, and then you send it back to the alert.
Yeah.
To the forest watch.
Yeah. We make public the information with more detail, and then we send that back the information for them, saying it was discarded because it was just seasonality, discarded because it was planted forest, and so on for all of the systems. Okay, thank you. Yeah.
Does MapBiomas have plans to expand to other countries or just stay within?
We just expanded to all South America. We are missing just Chile. We have here Santiago from Argentina, and we have published the data for all Amazon basin and for Argentina, and next year we have the first map for Indonesia also. So that's the land use and land cover system. They are ready to expand to any country, and it's all public. It's all transparent. So there is no cost to use anything. Just we have to make a training for the concept is map is produced by local entities. Okay, so you go there and train them to produce their own maps. We will never produce any maps from for other countries. And map alerts is not ready to transfer to other countries, because we still defining if you use Planet or if you use Sentinel. When we define that, it will be ready to transfer also.
And right now, GLAD is only limited to Amazon, Congo, and Southeast Asia.
To all tropical first. Glad gets all tropical first. Just don't get the south and north of, but all country like it takes all African forests also. Okay.
Okay. Hi. My name is João Siqueira. I'm from Amazonia. Today I will show a little bit of our app, right? But I will start with a story. Who has a car here? Okay. Who has a license to drive? Okay. Now imagine you are in your car driving faster. You are exceeding the speed limit, but you don't care. Okay, and you are driving, and for a moment you face this guy. Okay, what is this? Speed trap, right? Okay, when you see this guy, what do you say? You say crap. Okay, okay, you well, this is a big problem, but you can't do anything now. Okay, okay, you you get slow a little bit, right? And follow your path. Okay. 2 days after, you receive a letter in your house with a thing like this, right? Uh, Here is Portuguese, but is I don't believe. What you do? You pay. Yeah, $200. You need to pay because you are wrong, right? So we are trying to create a speed trap for deforestation to get. Okay, so if the first you committed a deforestation, you will receive a letter like this or an email, and you can't do anything, just pay, right? Okay, so here is our prototype of a speed trap for the first station. Okay, Marcos has introduced the app here. See, it's a single tool, but it has a lot of code behind this. Here we can choose some range of dates, biome, state. Here, I think no, a state, municipality here, and alert here. Okay, so I have this alert here, and I choose two images: a image before and an image after the first station, right? So here is a Google image. Okay, this is my first planet image is before the deforestation, and here the second image is after the deforestation. Well, these alerts is almost this area, but I have this another area here as well. And I can get some samples. It's a hand draw polygons. I have polygons for deforestation, for chained areas, and the polygons for non-chained areas. This is a edger a boundary to limit the region where the random forest will classify the image, right? And we'll collect 100 points inside each class, process with 12 trees, and get a new polygon like this, right? So I have a big region here and a small region that cross the initial alerts. Okay, so we had a raw alert here, and now we have a more detailed alerts that give us more information. Okay, this is a new polygon. We will export this. We will uh, put this information in our database, and this polygon will appear in our platform in web, the Alertas MapBiomas, right? Okay, this is a single process when you have just one alert to do. But in the last 2 months, we have 12,000 alerts to do. How many people are working doing doing this process? Okay, this is a big job, but we need to do, right? Okay, now I ask your help to do some alerts for us, right? Just click here, and I will.
We'll share the presentation, but not on the website yet. Just use this link to get to Google Earth code editor with the code of the.
Maior. If you have some problems to access the code,
Go one, with them to show them how to do, how to choose.
mhm. Okay. Okay, right. You can see the app. Okay, the first of all, we need to select this date range, but there is a default range here. You can change or not, but I will change for June, 3 June, right? I will select a biome, okay? I'm from Amazonia, and I will refine a alert from Amazon. You can choose anyone. Okay. Now we can load these alerts. Just click this button, load alerts. And this here we see those alerts from Amazon here, right? Now we can select from alerts from a state. We are applying some filters to select just one alert. Yeah, it's glad, sad, from imp. It's uh, a lot of sorts of alerts.
We merge all of these alerts and solve the polygon to have one polygon for each of them. Okay. But here is also we have a pre-validation automatically to remove any alert that does not fall in a forest.
Okay, I will select the Mato Grosso state here. You can select another one, and I will select the Alta Floresta municipality here. And here we have some IDs for each one alert here. I will select this one here. Okay, if you want to select the same, okay, and the alert appears here, right? And I will find some all of images that has that have the dates between October 2018 until June 2019. Find images and is loading. I hope. Okay. Those are some thumbnails. And the first image is the most recent image. And the last image is the oldest image. Okay, 2008, 18. Okay, now we need to choose two images. Image where you see the deforestation perfectly, and another image where you see the forest. One of those looks good, right? Okay, this is forest, forest, forest. I will select the this one and select deforestation image. Avoid the clouds, of course. Here. Okay, now the two images loading here. Uh,
You could also, if it's not a real deforestation, you could click here in not validated
not
also.
validate.
It will open a menu saying why it's not real, and then we save this information, send back to them.
Okay, well, to collect some samples, we need to select these draw polygons option here, and you can start to collect. We need to draw polygons, not points. I will draw a polygon, a bigger polygon, to involve all this area here.
You can add transparency to the second image also.
Mhm. Okay, and I can define it as my polygon. This is a edger
Boundary.
to boundary the classification. Okay. Oh, in turns green is my boundary for classification. Here is my another image, right? And I can see clear the deforestation. I can use two options to define the region where I will classify the deforestation. I can use the alert region or this my polygon region. If I will use my polygon region, I need to select these options here. Use my polygon. Okay, and now I will collect some samples for deforestation class. Okay, here I have a region that changes here and here. Okay, I can collect a sample, right, and set as deforestation class. Click on this button here, and turn is yellow. I can select another one, set as deforestation.
Does it know which image you're working on when you do that?
Yeah. Uh, and now I will collect some non-changes polygons. Well, non-changes could be forest or non-forest. I will set as no deforestation, and here I will collect a sample from non-forest to non-forest. Yeah, I recommend to use a mouse. It's better. Yeah. No deforestation. Okay. So we have our region, our samples, and this alert that help you to find the real deforestation. Uh, you can unselect this option to not select a sample that you don't want, right? And click classify. Okay, it's loading. Okay, we have two layers. It's a raster layer and a vector layer. You choose one to see. We can look both. Okay. Sometimes the deforestation is too complex. Is too hard to collect samples, and you can redo the work, deleting the samples, and collect another samples for each class. Here we can apply some filters, spatial filter, right? In these sliders. This slide is to remove noise from the deforestation class. That one is to remove noise from not the deforestation class, right? No, looks good for me, of course. Uh, Now you can export this polygon, but all of this data is in our asset. We have a big asset to store all the image, the plant image in the polygon. But you can export for your own account, right? You click export button. Will appear a task in the task tab here. Uh, okay, here we have 4 tasks uh, for this polygon here. We have the samples. We have the second one is this alert here, but these new alerts cross 2 alerts more. Uh, so we can merge this information in a unique polygon, but we export all this information because we have some other polygons here crossing this region, and we need this information in our database. I'm clear? Or-
We saw just one alert,
Yeah.
but it probably had another alerts here from other sources. So we are exporting all the polygons that crossed to remove them to say, okay, it was real, but it was exported already. Okay, just to keep this information.
Yeah, important information is the centroid is crossing with this new polygon. The centroid of the original alert is crossing with this polygon here, and we can export these things here. You can choose a place in your account, in your asset to store this information. Yeah, it, that's all.
So in the link that you have, all the code, it's open. You can change it and
So if you're when you're want to create the polygon for the deforested area, if the classification for whatever reason is soil surface complexity or something's too noisy, can you just use your hand drawn polygon as the input of that goes into the system as a confirmed deforestation, or are you forced to use the classification?
Yeah, sometimes it's easier to draw a polygon.
Yeah.
Eh, Instead, you collect samples and classify. Sometimes you have a rectangular deforestation. You can just uh, draw the deforestation. But is the
we decided not to allow that. What you can do is when you set your polygon, if some area is the classification is passing, you can set a polygon and you classify just inside that area. So you can limit to remove that noise. But we decided to not let the user draw polygons to avoid maybe some user mistakes. So you need to collect samples. We now have a lot of samples that will get in this screen with one version classified already. So he can say just okay, that's good, or no, I will get some samples and classify again. But we decided not to let the user draw the differentiation.
Yeah, if you have a central system with multiple users, you need some standardization.
Yeah, yeah, yeah.
Okay.
He and then
You first.
yeah.
So thanks. So when you get an alert, you use it to query Planet's database. You make these image chips. You store them on Google Cloud. Then you use a script to bring it into Earth Engine of some kind. How much does that cost per for the imagery? I mean, you've got a lot of images here available. How much does it cost you per alert or per tile or whatever?
The image of planet they you pay by for one area and then you receive uh, the all image for 1 year of this area. Okay, you don't pay by image.
Mhm.
You pay by region, And when we buy, we usually buy 3 months before the alert. So we'll have image for more 9 months after the alert. So if it's increasing during the time, we already buy the image for this region. We buy a region by 5 by 5 kilometers. The usual areas that they sell is 25 by 20, 25 kilometers. But we're still having a lot of negotiation with them to buy just the image before and after on this kind. It's still a lot of negotiation. That's why we are not ready to send to other regions, because there is a lot of commercial negotiation. That's why also we have a solution with Sentinel, that for alerts with more than 3 or 4 hectares, Sentinel will be enough to solve it. Probably Planet would be needed just in small alerts, not.
So, I
So
mean,
that
do you expect that it will be very expensive?
uh, no. Norway had opened digital a proposal to buy Planet's image for all tropical region and to give it free for every country. So we expect maybe next year it will be free also to use in this kind of solution. The government of Norway are buying and making it free to use. But now it's kind of expensive. This project, we are just in image, we are spending like $2.5 million. That was donated also by Norway and other non-governmental, because it's a research project to develop the technology and to make it free to anybody, to any country and region that wants that. That's part of our commitment. That's all. It's all open, all transparent. All the codes are free. Just, he has a question. Then
Sorry, two quick questions. One is, in your pipeline, which points or point or points are the bottleneck? Like, what stops you from going faster? And the second question is, how do you sort of close the loop? Like you said that you had started to, for example, to put a fine, or to ultimately we want to reduce deforestation. Well, how do you link to the last step of getting that done?
let me go here. And anywhere where we have people are here we have a visual validation to avoid buy high resolution image where there is a false alert. So here's is a fast one. Just make next, see see the alert, see high resolution image, and say it's false, why it's false, or it's okay. Then it's fast. This is operation that João just showed. In this point, as we have to select the images and collect samples, is still very slow. And we have now to have like 20,000 alerts for Amazon, and we have a lot of teams. You have like 50 people working on that, but it's not possible to replicate having a huge team like that. So that's the two problems. We also have here on the website, when I get like, here's the list of alerts. We have here a form of any action that was taken on this alert. So this all the prosecutors, the guys from fiscalization, they can add this information here. Now they add one by one, just to establish the format, but we will link in their system. That's why you have a unique ID that will follow this alert for the rest of their life. So when they apply a fine, they will add this ID of this alert, and then we'll have in the public information any action that was taken for all of these alerts. If they went to the field and it was not confirmed, or if they went to the field and they applied fines. And we have just like in Paraná, they went to the field and they confirmed all of these alerts and they apply new fines. In Bahia State, we have 4 civil inquiries already on this area. So we are starting to get some results from the use. But what we want is to open the precedent to send these fines by mail. That's the and one important thing in Brazil, when you do this deforestation, you may receive the fine 5 years from the date, 10 years from the date, because you commit a crime to remove the forest, and each year you commit a new crime uh, to keep the forest from regrow. So you are we are committing crimes each year. So if this government don't want to make a fine to you, the next one may say, okay, you planted soy, you received a lot of money. This money will come as a fine to you for using illegal area. So that's important. That's why it's important to be public, because in 5 years from now they can look and apply fines for the guys that are deforestation today.
Thank you very much. Very important results and very useful for all of us. I have a question for the ingestion of the images. Do you have a particular license with Planet Labs to have it shared in Planet and process there?
We still have a lot of commercial discussion with them. Now we have an API. We send them the code of the area that we need to buy, and they copy this image to our Google storage platform. And from Google platform, we ingest it to Google Earth Engine. It was that's a partnership with Google also, and they made a code that improved this ingestion. It's public also, this code. Yeah, you have the
Yeah, it's a code that is in the MatHencher GitHub. It's a Python code that uses Earth Engine to ingest all of these images.
but that's takes time, more time that we expected.
Our if I ingest using my accounts, uh, I can ingest 40,000 images per day. Google ingests 200,000 by day.
Using their own accounts, but we still have 2 million to ingest. So it's like 10 days to ingest. So this is changing. We are trying to validate before to ingest in Google Earth just the previews and the image that will be used. Just ingest 2 images inside Google.
Yeah.
That's what we are changing, because really it's taking a lot of time.
Yeah, we are trying to select outside the Google Earth Engine this selection.
Thank you. This is amazing, and I think the goal of mailing the fines is really important. But what about in terms of deforestation in national parks or protected areas where there isn't an individual address or person that lives there, but there's still deforestation going on? Could you imagine like a mobile app that park rangers or local enforcement can use to go check on the area and monitor what is going on?
We discussed that, but Brazil is too huge. Like the conserved areas, we have 2 or 3 park rangers, and uh, they must see first in the image, and then they need to go. And when they go, they have to go with federal policy also, because otherwise they will be received with fires, and that's so. We all of these deforestation inside conservation units are all illegal. So they are we cannot cross with property information because there is no. But most of this deforestation, the guys trying to make the deforestation, and he will try to say he was in this area before and try to legalize these properties. So this information will also help to avoid illegal claiming by the area. That's what happened in the Amazon. But I believe we developed some field apps to cell phones, but not to this kind of function yet.
There's like smart works
Yeah,
pretty well
so-
for that, and the
Yeah.
Earth Ranger kind
Yeah,
of,
yeah.
sort of stuff.
But I was going to say then maybe they can take photos on the ground and that can confirm as well whether or not it was
Yeah,
It's a
maybe.
very different animal when you think, like, I'm in Cambodia, which is a small country, and then you have, discrete protected areas and people that are responsible for patrolling those areas. So getting that information to them is very, very efficient. So,
Yeah.
this is perfect.
Yeah, in kind of Brazil, we don't have people walking this area. It's very huge area, so that's why we need to see first in the satellite. Then people can go to the field to apply fine. That's it, guys. Believe it. It's wait, time is done already. Yeah, today it was until 2 o'clock.
It's funny.
We'll be here if you guys have any doubts. We'll be happy to help you guys.
Do you get support from the government? Like, what? How the government think about your
We had agreement with the previous government. This government nowadays we are trying not to fight with them too much because they reduced all the money for fiscalization. So we are trying to generate with that also a lot of pressure in the public information. That's why it's all public internal, and we are preparing English version also because we need pressure on this actual government because they had one speech in favor of, oh, it's a industry of fine, but they also have a speech of they will end the illegality. So we are trying to, okay, 90% of these alerts are illegal. So okay, let's end the illegality. But we still have an agreement with the government. They use this data, just the federal as state. Uh, they are using that, but not guarantee.
Do you ever worry about like your security because people on the ground who are trying to protect the forest sometimes get attacked by people trying to take from the forest?
I hope. I hope it's not that yet. I hope you don't. Yeah, yeah. Yeah, we had some offer to move the project outside of Brazil yet, but I believe it's too early. We're still being free to publish data and to talk about that. But they already said, oh, who is publishing data about deforestation? It's not a patriotic. It's not does not like Brazil or something like that. But we still don't feel that we have any threats yet.
It's extremely relevant in some places. Cambodia, people get shot and killed over this.
Yeah, people in the field also get shot in Brazil, but I believe we still have some. Let's hope we don't get in that stage yet. Okay, guys, thank you.